Alright, so here we are with Chapter 2, problem number 68, which reads, a toy train is pushed forward and released at x of I equals 2 meters, with the speed of 2 meters per second. It rolls at a steady speed for 2 seconds, and then one wheel begins to stick. The train comes to a stop 6 meters from the point at which it was released. What is the train's acceleration after its wheel begins to stick? So you can see I've already written down the given information. This problem actually isn't too difficult. It's just a matter of thinking about what is occurring. Alright, so if we want to know what is the train's acceleration when the wheel begins to stick, we need to know first how far is it going to travel before it sticks. Okay, so to do that, we're going to start with just some basic information we have here are V equals d over t. And we know for that section of push that it moves, where it's not sticking, it's going to move with a speed of 2 meters per second. And that's going to occur for 2 seconds. And then we have our distance here that we need to solve for. So we know then that the distance that it travels before the wheel begins to stick is going to be 4 meters. Therefore, the train is going to accelerate, or in this case we could call it decelerate, for 2 meters. Okay, and that'll be really important information for us. So to find out what the acceleration is for this 2 meter section of the track, and we get 2 meters because the total distance that it moves is 6. So we move for 4 on a constant velocity, so it means it sticks for 2. Right, so if we're going to find out then what is that acceleration, we're going to look at our kinematic equations, and I like v sub f squared minus v sub o squared equals 2ad because we know nothing about the time. The time for the section with which it's sticking. So we're going to find an equation that has no time in it. In this case, that's what we've got here. So v sub f is 0. The initial speed is 2. And then we have 2. And the distance that it moves is also 2 during that section where it accelerates. And then we have a. So we get negative 4 equals negative 4a. So it's going to give us an acceleration of negative 1 meters per second squared for that section. So that was Chapter 2, problem number 68.